Okay, also with, if we were to talk about being symmetric to the origin, so symmetric to origin, you would also see that this type of circle, where our center point is at 0, 0, which is the origin, this circle would also be a good example of that. Another one that would be good would be, let's say, y equals x cubed, where you would have something like this, where it's going through the origin. So you could flip that a couple different ways to, to play with it if you wanted. You kind of like take it as a knob, like a doorknob, and just turn it left or right, and you can see it's going to be reflected in each of the quadrants. So it is symmetric with respect to the origin. Trying to think of another example. Not coming up. How about something like this? So what if we had something like that, just like in your book? You would have points that would be the same. This is going to be x, y, and this is going to be negative x, negative y. So they're the same values, they're just opposite signs. And that's another way to tell if it's symmetric with respect to the origin. Okay, next we're going to look at determining if a function is even or odd. And really all you have to do with this is just have some function. So let's say y equals x to the 5th power plus 2x cubed minus 3x. And so we've got this function here, and we want to know if it's even or odd. So the best thing that we can do, need that for notation here in a second, is simply replace the x with a negative x. And if we do this here, all that's going to do is replace every x that's in the function with a negative negative x. And now what we want to do is figure out if f of negative x is equal to f of x, then it's going to be even. But if f of negative x is equal to f of negative x, then it's going to be odd. Okay? So really that's all it is. So let's go ahead and check this one out. So all we have to do now is raise negative x to the 5th power. Well, it's being raised to an odd number, so it's actually going to stay negative. If you need proof of that, just go ahead and write it out 5 times. So you got negative x times negative x times negative x. Now multiply those two together. You're going to have a positive x. You're going to have a positive x here. And these two positives will be again positive. But you have this one left over right here that's negative. So when you multiply this x and that x together, it's actually going to end up being negative. So that's why I just said with this being an odd number, you're going to multiply together an odd number of whatever you have. In this case it's x. So therefore, since it's negative, it's going to remain negative. So same thing here. This is an odd number, so this is still going to be a negative x. So that's going to be minus 2x. Now, is this one raised to an odd number? Well, yes it is. You don't see a number there, but when we don't see it, there's always a 1 raised there, and 1 is odd. So this is still negative. So that negative is going to come out in front and change the minus sign to a plus, and you have plus 3x. So let's write it out one time here. we've got negative x minus 2x plus 3x. And we can definitely see that this is not equal to the f of x, which originally was, which is not equal to the original function. All the signs have been reversed. So in fact, this function is going to be odd. Now let's look at this one. And again, we're just going to plug in a negative x. So therefore we're going to have 2 times negative x to the second power minus 3. And since it's raised to an even power, that's going to mean there's an even set of numbers that are going to be multiplied together. So in this case there's 2. So 2 negatives multiplied together are going to be positive, so we have 2x squared minus 3. So in this case, our h of negative x is equal to h of x. So therefore, this is an even function. I think I forgot to mention, if f of negative x is not equal to f of x, and f of negative x is not equal to f of negative x, then this is going to be neither odd or even. So, an example of that will be something like this. X squared plus 6x plus 9. Again, all we have to do is just plug in a negative in there. And that's going to look like this. Now we just evaluate. So this negative x squared is going to end up being a positive x squared. The positive 6 multiplied by negative x is going to be negative 6x plus 9. So we can see this does not equal the k of x. So the k of negative x is not equal to the k of x. So therefore it's not going to be odd. And now we just have to check if this is equal to, so we're going to check if that is equal to this. So we're going to take this function, which is, and simply pass a negative through it. So think of it as negative 1 being multiplied to each one of these. So this is going to be negative x squared minus 6x minus 9. As you can see, these two here are not equal to each other, so therefore it's not odd. And because this one is not equal to that one, it's not even, so therefore this one is neither.